Hey everyone! After my last video about Synology restrictions, I got some more comments and questions from people asking about building a NAS or home server at home. So today I decided to give you this video with a sort of a roadmap. I want to see how far and detailed I can get in this video, and if it's not deep enough, then I'll make a follow-up. So if you've ever wondered why you would want a NAS or a home server, or what you can actually do with it, or what options are out there, the budget, the time, the goals, and what you want in terms of hardware, software, and functionality, then this video is for you. So let's start with the basics. When people say NAS, network attached storage, or a home server, they usually want a system that can do at least one of the following things. First, you want a system that can act as a central file storage, so you can store and access all your files across all your devices. Next to that, you probably want it to provide data backups, so you can automate backups for your computers, phones, and whatever media devices you have. You probably want it to act as a media streaming server running Plex or Jellyfin, so that you can stream your movies and TV shows. Perhaps a personal cloud as well, for example, a Nextcloud, so you can sync files across your devices, kind of like Dropbox. Self-hosted services, Bitwarden, SyncThing, Pi-hole to block like ads. And then maybe you want also to host virtual machines so that you can experiment with VMs, Docker, Kubernetes if you're into developing. Some people use it to store surveillance system footage from your security cameras. And it also can be just a way for you to tinker with things. So you can try out the sysadmin skills if you want to play with the Docker containers and so on. Naturally, your decision on what hardware you use or you want to use depends on what you want to do with it. So how much money you want to spend, first of all, but also how much you want to tinker and maintain it. And also how performant you want it to be. So in this video, I want to walk through 5 different ways you can set up your NAS and see how you can get there. So level 1, USB drive into the router. This is a very simple way to have NAS-like functionality when it comes to accessing files over your network. And to get it up, you just plug a USB drive into your router, log into your router's admin page, enable USB storage or file sharing, depending on how it's named, choose SMB, stands for Samba, or FTP, file transfer protocol, and maybe set up a username and password. The difficulty here is very low, so it's about 1 out of 5. And it's super easy, just basic settings, and the router's interface usually guide you through it. As for the maintenance, once it's set up, there is really nothing to do. You might need to reconnect the drive if the router reboots, or be aware of the risk of data loss if the driver fails, since, well, there is no monitoring or setup for redundancy. It's just a drive connected to the router, just like it would be connected to your home PC. So as a verdict for super basic file storage, this is plug and play. And even though it's not a real NAS or home server, I wanted to outline this first basic option because many people forget it actually exists. They think about buying a separate box or a server, but you can actually use just your USB drive. Don't forget to back up your data elsewhere just in case, but it's a very simple way to have network storage. All right, so at this stage, you no longer just plug in a drive into someone else's router. Now you're hosting your own operating system and services, usually in a small box. That will give you more flexibility and also responsibility. For a thing like Raspberry Pi, you can already start adding services. For example, as I mentioned, Nextcloud for data synchronization, Plex for media viewing, Pi-hole for protecting your local network from showing you ads, and all kind of other things. And I put Raspberry Pi here as a name holder. The Pi's got a little bit expensive lately for what they are, so unless you need GPIO or some specific feature that's only available in Raspberry Pi, you can also consider Intel N series CPUs that are interesting to look at. And finally, there are also many alternatives to Raspberry Pis in the single board computer world, and I will put something in the description below. For example, Le Potato from Libre Computer, which is basically an alternative to Raspberry Pi, which is a bit more affordable and provides the same functionality. So let's say you have your little computer with an external drive, and now you want to have a simple NAS home server installation, and you want to install OpenMediaVault. So you don't need to do much for this. There are various tutorials online. For example, for Raspberry Pi, there is a good guide for that on Pi My Life Up. You basically need to get an SD card, install the OpenMediaVault on it. After that, after the OpenMediaVault is installed, you boot the Pi, access it through the web interface. You can mount your external USB drive, and after that you configure your SMB or NFS shares for network file access, and optionally install services like Plex, Nextcloud, or Pi-hole. I'd say this would be pretty straightforward and cheap, and I'd say the difficulty here is about 2.5 out of 5. You'll need to follow a guide, and you might need to use the terminal for basic updates, but OpenMediaVault web interface makes it extremely beginner friendly. So here I want to say a bit of words about OpenMediaVault. OMV is a lightweight and designed for low-powered hardware like a Raspberry Pi. It also has a very simple web interface that hides most of the complexity, and it focused mainly on file sharing and basic services like SMB, NFS, and AirSync, and it works well for setups with 1 or 2 drives. So whether that's a USB or a small SATA array, it would work well, and it's basically a plug-and-play NAS operating system for small setups like Raspberry Pi or Intel NUCs. As for maintenance, you'll occasionally need to update it, so through the web interface or by running an update in the terminal. And if the power cuts out, you might need to manually remount the USB drive. So hardware maintenance will be minimal at this stage, and if you want just a simple home server, that's a great solution. It can also grow with it, and while it needs some skills, there are no deep Linux skills if you need to stick with the OpenMediaVault, so it's a good option as a first system. Now on level 3, on the repurposed PC, here's where you gain a little bit more power. You're no longer limited by a small ARM board like Raspberry Pi has, or an N CPU from Intel. You have a full x86 machine that can handle more services, heavier apps, and even virtual machines if you want them. Setting it up might look similar, but the hardware will open more doors. You can install much more powerful operating system, for example, just a normal Linux server like Ubuntu server, TrueNAS scale, or Unraid. And then you can configure your storage with more drives than 2, maybe setting up a ZFS pool or another type of array. You can still install Plex, Nextcloud, or Docker apps and configure automatic updates or backups for it. But with a machine like this, you can actually, for example, serve more users via your Plex media server, maybe even set up a small Minecraft server as well, and things like this. In terms of difficulty, if you go with a Linux server and install everything manually, then it would be probably like 4 out of 5. Despite that, there are many instructions available on the web. And if you choose a web-based system like TrueNAS or Unraid, then it would be closer to 3 out of 5 because a lot of things are done for you just through the web interface. A good question here would be, why would you go beyond OpenMediaVault like in the example of Raspberry Pi? Well, OpenMediaVault is fantastic for small setups like Raspberry Pi builds, but if you're building a bigger machine with more CPU power and more drives, you might want something advanced, more advanced. For example, ZFS file snapshots, native Docker support for virtualization and containers, virtual machines, of course, and that's where systems like TrueNAS, Unraid, maybe even Proxmox come. So they will unlock you more flexibility, configurability at scale, so that, of course, at the cost of more setup and maintenance. At this point, with systems like Unraid and TrueNAS, you can get pretty far with the web interface. The web UI options make things much easier. Installing Docker containers will be kind of a new task for you. And although you can always just copy-paste commands from official documentation or instructions on the web, because there are plenty of them. Having said that, at this point, you should be comfortable running things in the command line. In my case, I use normal Ubuntu server simply because I'm familiar with it and I have no problem using a command line most of the time. I set up everything that I have manually, also just because I wanted to have fun of doing so. But depending on your skills and your aspirations, you might consider alternatives, also because they have their own NAS-specific special features that offer a lot of advantages. For example, TrueNAS focuses on ZFS file system, which is self-healing storage that provides snapshots, redundancy, and TrueNAS also can run containers and virtual machines right out of the box. So it's great in terms of data integrity. It's great because it's set up and forget, and then you might be sure that your data is has integrity until you get a notification that you need to fix something, but then it also will provide you these notifications. Unraid is similar to that, but a little bit different. It offers very flexible storage. With Unraid, you can actually mix different drives, different sizes of the hard drives in a sort of a distributed pool of drives, spreading your data across multiple drives. Similar to RAID, but with RAID, you need to have the same sizes over hard drives, and Unraid allows you to mix and match different sizes. It also has Docker container setup, very easy, all the plugins for media servers and backups, and very friendly user interface, which is also true for TrueNAS that I mentioned before. Something that I mentioned here is that in addition to choosing your operating system, you can also pick a more advanced file system. I just mentioned ZFS, so instead of a standard Linux file system like ext4, many people will choose ZFS, a native system in TrueNAS, because it adds, as I mentioned, self-healing, checksumming, and snapshots, features that usually would be found in enterprise storage for reliability and integrity. Okay, so with the next level, we actually try and use the enterprise-grade machine inside our home or a home office. So a rack mount-like server setup usually makes sense when you want to scale beyond what a regular PC can do in terms of, well, capabilities, hardware, and so on. And if you want enterprise features like remote management, redundant power supplies, maybe even hot swappable drives if you have a lot of them. Some people perhaps do. And naturally, it will come with some drawbacks. So a rack mount server is louder, heavier, uses more power, and it will need more maintenance. At the same time, there are many used enterprise servers that are decommissioned by large companies and enter the used market for quite an affordable price. You can get that at JBOD. A JBOD stands for just a bunch of disk box that you can put the hard drives in. And then you have your very own home server of enterprise level and a nice box that you can fill in with your with the hard drives that you probably can also buy used. People who set this up usually go with installing an operating system like TrueNAS that I mentioned, or Proxmox. You would connect your JBOD expansion shelf with the SAS cables and then you can set up large storage pools for this, whether the ZFS or hardware RAID, and well, configure the same services as I mentioned in previous sections, but now scaled up. What you need to account at this point is the cooling, the power capacity, and UPS protection from the from the energy surges. I'd rate the difficulty here at 4.5 out of 5. You'll need to be comfortable with enterprise hardware quirks. You might need to flash firmware or configure RAID controllers at some times. The operating system installation is similar to a regular PC, but hardware adds more complexity. And sometimes you'll run into noisy troubleshooting, for example, fan alarms or SAS cable issues. Having said that, again, there are plenty of people on the internet, let's say Reddit Home Lab subreddit, where you can get a lot of information on troubleshooting. What I also would suggest at this point is that with a rack server, you probably want to have a clean airflow for it for cooling and also monitor power consumption. So with a verdict, this level is for hardware geeks or home labbers. I don't think it's very practical unless you're really into this stuff. And it's definitely not a setup and forget system. So you'll need to actively maintain enterprise gear at this stage. Finally, now we're coming to the last 5th level in my list. Around this level, you are no longer talking about one machine running everything. You're talking about multiple physical servers working together as one system, essentially giving you a home cloud. And to do that, you'll need something like Ceph. So Ceph is a distributed storage system that can pool storage across multiple machines with redundancy and self-healing. And to give you more information about that, I spoke with my friend Fardjad, who built his own home cluster with Proxmox and Ceph after his Synology NAS failed him. Hello, Fardjad.
Hi, Dimitri. How are you doing today?
Very good. How are you?
Yeah, I'm pretty good. Excited about the episode.
Super. So I wanted to call you and ask you a bunch of questions about your home setup because I preparing a new video about differences between home servers and what you can do with them and different types of them. And so far I've been exploring scaling, let's say vertically. So just what can you do if you have a beefier and bigger machine? But I also know that you have your own home cluster. And you also had a past with Synology when it died on you.
Oh, yeah. So I bought a Synology unit a few years ago because I was just tired of synchronizing my files to cloud providers. I will not name names, but there was one in particular that was super slow, and yeah, it was not really interesting to use it as like long-term storage. So I wanted more storage, and I bought a Synology unit. And it was really great because the software is easy to use. You can get started in relatively no time. And the built-in software, the ones that are available through the marketplace of, I don't know what it is called anymore, but yeah, that the Synology App Store thingy, is very, polished, I would say. Synology virtual machines are just fine, and my problems were related mostly to my setup or the way I configured my home lab. But you make trade-offs, right? So, anyways, I was living with this for a while until the device failed on me because the restart button that's also soldered to the board broke, and I think that's a common issue. Like if you go to the support forums, you can see multiple reports of people facing the same issue. And then I contacted Synology support, and they couldn't really give me a solution, and I actually lost data.
So Fardjad originally used his Synology NAS, but after it failed, he decided to move on to something more flexible and resilient. And well, I wanted to know what made him decide to build a cluster, a home cloud, instead of sticking with a single machine.
So I was looking for an excuse to do something else, to be honest, and well, I had a few mini PCs lying around, so they're not the same, or they're not like exactly identical machines, but so I bought them for different purposes. So, for example, at some point I needed a Windows machine to do something, and I was not really going to run it on a virtual machine, and I had like a Apple Silicon, which was not playing nicely with most of the virtualization tools back then. So for different reasons, I had those. And then, well, I made a cluster of like machines with those and decided to run whatever I have on them.
But so the PCs, the units that you have, I think those are Intel NUCs, right?
Yes, that is correct. So one of them is actually not really an Intel NUC. I bought that because I got excited about how you can power that unit up. So it just powers off of a USB-C cable.
Okay.
And then I don't need like an extra adapter and whatnot. And so there's that, and then two Intel NUCs, and then an enclosure for the drives, which I connect to, or I could connect to one of these machines. And that's that gives me like my drives back, and I can create a new storage solution on one of those.
And the enclosure is JBOD enclosure?
Yeah, it's a JBOD enclosure. But then at some point, so I'm actually in the process of rebuilding like a better solution on which I have more control, but then it's separated from all those other machines. So I just disconnected that and then put SSDs on all of these three machines, and decided to run all my virtual machines on them. But because I wanted them to, like I wanted my virtual machines to have high availability, I installed Proxmox on each of the nodes, and then created a Ceph cluster with all of them, so that there's shared storage for like running virtual machines off of these machines. And what that gives me as a benefit is that when I run a VM off of one of them, and then I migrate it to another node, it just takes a few seconds for it to finish, because all of them have access to the same kind of storage. And what it needs to do is that it needs to create a snapshot of the RAM and puts it in durable storage, and then resume it on another machine, provided that there are enough resources, or the conditions for running the virtual machine on another node are met.
In essence, Fardjad has a hardware setup of 4 boxes, with 3 of them being mini PCs, and 1 his storage with hard drives. And together they form a home cloud where the operation continues even if one of the PCs goes offline. So the memory, the RAM, and the storage of those PCs is distributed in that home cloud.
So I'm running Proxmox on these mini PCs, as I said, and it has a very good integration with Ceph. In fact, you can create and manage a Ceph cluster with it, which is what I've done. And Ceph is especially interesting for me because, well, of course, it allows me to use all these SSDs that are attached to these mini PCs, but it also allows me to run virtual machines on these mini PCs very reliably. And what I mean by that is that, let's say I'm running something like this Home Assistant instance on Proxmox number 1, and then I decide to do some maintenance on this node. For example, I decide to upgrade the operating system. So what I can do, because the storage is sort of shared across all of these Proxmox instances, I can shut down this Home Assistant virtual machine and like power it back on another one, or better yet, I can create a snapshot of the RAM, and this is, by the way, done automatically and seamlessly by Proxmox. So it can create a snapshot of the RAM, store this on durable storage, restore that image on another node, and then run it again, but on another machine, which is a huge game changer in terms of, maintenance without major interruptions. And this whole process will probably take a few seconds.
So in the end, I asked Fardjad what advice can he give to anyone thinking about building a cluster like that.
Well, yeah, it's hard to give advice. So I do it because I like it and I want to learn. And doing this helps you understand what happens underneath, and it's basically good for discovering new software, or just becoming. I'm a software engineer, obviously, so it helps me be a better software engineer in a nutshell. But if you want to do it, make sure that you can maintain it. So especially if you're going to store critical data on it, so it is as good as the ability for you to restore your backups and recover from disaster scenarios.
Exactly.
So just you need to practice this regularly to make sure that everything still works, your backup scripts work, you're doing or like your system is doing what you think it is doing. Otherwise it will be too late and you will lose data.
And by the way, if you want to listen to our interview with Fardjad in more detail, kind of like a podcast format, I put a link in the description below to that full interview in a different video. Next to that, a separate video that Fardjad made on the full tour of his home setup is also linked below. So if you're interested in the deep dive, then check it out. So in terms of difficulty, I'd rate this as a solid 5 out of 5. If you want to build a system like this, you'll need deep knowledge of Linux, networking, storage systems, also familiarity of debugging stuff and building stuff and not be afraid of trying out. You'll have to monitor the cluster's health, replace failed drives, rebalance storage if needed, and be ready to troubleshoot distributed systems when things break. So this level is enthusiast and home lab territory. It's not something you build just to store files. I would say it's something you build because you enjoy learning how it all works together. So as you hopefully saw for yourself, depending on how much time, budget, and learning you're willing to invest, there's really a home server path for every need and imagination possible. Maybe you're happy with the USB drive that is attached to your router. Maybe you want the flexibility of an actual separate computer like an SBC or Raspberry Pi running its own services. Or maybe you're ready to build a full rack or even a cluster. No matter where you are on the path, I think it's your system, your data, and your choice. It's also a lot of fun and makes you independent from whatever company that tries to sell you hardware as a box. And so I would suggest try it out and see where you end up. So on this note, I hope this video was useful to you. If you have any questions or comments, leave them below and I will be super happy to answer those. Also, if you have any cool stories about your home setup, share it as well. There were some nice comments and stories on the previous video that I made about Synology. Also, maybe check them out. And on this note, thank you for watching and I'll see you in the next video.